Guys, you're welcome once again to another fascinating math video. This time around, we're considering a video taken from trigonometry. But before I provide a solution of this problem on the board, I'd like to inform you that I render a private online math tutoring service for the primary level, secondary level, up to the college level. And I also offer services for schools, remote services. So if you need of my service, you're very free to get across to me because I'm a tutor that have a practical teaching experience which spans over a decade, tutoring various students across the educational level. All right, so let's quickly look at the solution on the board. Now, in this problem, we're required to prove the identities. The first of the problem is sine of beta plus sine of 3 beta plus sine of 5 beta over cosine of beta plus cosine of 3 beta plus cosine of 5 beta equals to tangent of 3 beta. We have to show that this left-hand side is equal to the right-hand side. Then second, now this second problem, I may prove it, I may not, depending on the time. So if there is time, I will consider it. But if there's no time, I will leave it to you as an exercise. Does that sound right? Let's try. All right, now the first is sine of beta plus sine of 3 beta plus sine of 5 beta over cosine of beta plus cosine of 3 beta plus cosine of 5 beta equal to tangent of 3 beta. Now, how do we prove this? Now, to prove this problem, it is important to recall from trigonometry the following trig identity. Now, look at it. If we have the sum of sines, that is, if you observe the summands at the numerator, the summands, look, consider this sine 3 beta, sine beta rather, plus sine 3 beta, you see that this is a sum, right? Sum of two sines. Also, we can also consider this second term and the third term. Sine 3 beta plus sine 5, that's a sum. Now, there is a formula for converting from sum into product of sines and cosines. All right, now I want to state the formula on the board. Now, if we have sine of x plus sine of y, this can be written as 2 sine of half the angle of x plus y multiplied by cosine of half the angle of x minus y. All right, so if you have this, you can write this, and we shall make use of this mathematical instrumentation. All right, so we want to convert from this sum of sines into the product of two sines. That is our aim. Likewise, we'll do that at the denominator. Now, for cosine, we want to get a similar formula. All right? We want to get a similar formula. Now, listen. For cosine, if we have the cosine of x plus the cosine of y, this is equals to write it 2, that is the cosine of half sum of x plus y times the cosine of half x minus y. All right? So we shall make use of these two formulas. You should do a copy of them if you've not seen them before, because we shall revert to them to prove this particular problem. So let me quickly erase this from the board. Make sure you do a copy of this, all right? And don't forget to like, share the video, and also make your comments if you draw any value from this particular math video. Oh, thank you. That is my friend over there. All right, so let me remove this. All right, so on applying this, let us take sine of beta and sine of 5 beta. You may ask me, why are you doing this? Yeah, if we should take the sine of beta and 3 beta, there will be a problem. But if we consider sine of beta and sine of 5 beta, you will see the results coming out in a very neat form. Let's look at it together. Now we have sine of beta plus sine of 3 beta plus sine of 5 beta to be arranged as sine of beta plus sine of 5 beta. I'll put this into parentheses plus sine of 3 beta. Can you see this? All right, so on applying that product formula I just quoted, this can be written as 2 sine of half of beta plus 5 beta. You recall that? So we have beta plus 5 beta multiplied by cosine of half of beta minus 5 beta. Can you see that? All right. So beta plus 5 beta will give me 6 beta. And 2 divided into 6 beta will give me 3 beta. Now observe you are seeing 3 beta here. Hence I made the choice of sine of beta plus sine of 5 beta. Can you see that? So when we divide, we have this to be equal to 2 sine of 3 beta. Now beta minus 5 beta will give me 4 beta. Minus 4 beta rather. And 2 divides into minus 4 beta, we're left with minus 2 beta. And it is a true thing that the cosine of a negative angle is a positive of the cosine. Is a positive of the cosine of the positive angle. All right? So that means everything here become cosine of 2 beta. The negative have to be removed because we have a law that if we have cosine of minus x degrees, this is equal to writing cosine of x degrees. All right? So we have this at hand. So we do similar to the denominator by using the appropriate conversion formula. Now the same thing applies here. We shall consider cosine of beta and cosine of 5 beta. All right? So in this case, we have it as cosine of beta plus cosine of 3 beta plus cosine of 5 beta to be written as cosine of beta plus cosine of 5 beta, let this be within parentheses, plus cosine of 3 beta. Now from that formula I quoted, this can be written as 2 cosine of half of beta plus 5 beta, which is 6 beta. Let me go straight to the point. 6 beta, all right? Then cosine of half of beta minus 5 beta will give me minus 4 beta. And this plus cosine of 3 beta. And this can be written as 2 cosine of 3 beta, then cosine of 2 beta. Can you see this? Then plus, don't forget this, plus cosine of 3 beta. Hope I do the same here. Oh, look at this. We omitted this term. Can you see this? You have to be very careful in order to avoid the mistake of omission. So this plus sine of 3 beta, let me add it here. Though it's rough, it's somewhat rough. You have to bear with me. All right, so we have this. So that means the numerator has been simplified to be this, and the denominator is now this. So we can say, therefore, the result is equal. Now, the numerator is sine of beta plus sine of 3 beta plus sine of 5 beta. And that has been simplified to 2 sine of 3 beta cosine of 2 beta. So we come here and write 2 sine of 3 beta cosine of 2 beta plus sine of 3 beta. All divided. Now the numerator is cosine of beta plus cosine of 3 beta plus cosine of 5 beta. And that has been simplified to this. So here we have 2 cosine of 3 beta cosine of 2 beta plus cosine of 3 beta. Now, if you observe the numerator, we can factorize as follows. What is common to these two terms? You see that the cosine of 3 beta is common to the two terms, right? So if you factor out, you have a sine of 3 beta. You'll be left with 2 cosine of 2 beta plus 1. Right? Are we right? Yeah, we're right. We're right. Okay, all divided by, the same thing applies here. What is common? Cosine of 3 beta is common. Factor out, we have cosine of 3 beta multiplied by 2 cosine of 2 beta plus 1. Can you see that? And you see that this exactly is this you see here, and they will divide that. So you apply the cancellation law. This will cancel out with this, and we're left with the sine of beta over the cosine of 3 beta. Rather, sorry, sine of 3 beta over cosine of 3 beta. Now, from trig identities, it's also true that the tan of theta is equals to the sine of theta over the cosine of theta. So on applying this law, we have this to be the tangent of 3 beta. And this is what we are required to prove. Don't forget to show that this is equal to this, and we've come to the conclusion. So folks, we've come to the end of this video. Please do me the favor to like, share, and make your comments if you draw any value from this video. And don't forget, very importantly, that I offer private online math tutoring service for the primary level, secondary level, up to the college level, and for schools. So if you need my service, be very free to get across to me. Thank you very much. Till we meet again. Bye.